Okay, welcome. This is our first lecture in our course on Intro to Programming C++. This is mostly about kind of the overall theory about how to write programs rather than anything specific to the syntax of C++. And this lecture is titled SIDS, which is an acronym for the different types of directions, sequence, iteration, definition, and selection. And we're going to go about that these are basically the building blocks for any program or really any set of directions, whether it's a computer language or not, and just give you some type of overview about that as well as kind of how they apply to C++. So our agenda for today is to identify the four basic types of directions, which I listed before. They are selection, iteration, definition, and sequence. Once we get that and show how they apply to different types of things we're going to be doing with the computer languages here, I also want to spend some time distinguishing between different types of errors. And in computer programming, you basically have two types of errors. You have syntax errors and you have logic errors. Syntax errors are basically about whether it actually works as a program, and logic errors is that did the program do what you intended it to do. It might compile as a program, it might be able to give an output, but it's not, in a sense, the logic of it. That if it's a game, it's like when you press a certain key, it's not going to, it's not responding the way that you'd want, or the output is not what it want if you're performing a set of calculations or something of that sort. We're going to link some of these types of directions to different C++ elements that we'll be learning this year, and we're going to try to illustrate some of these elements with examples. So let's dive. So I think the basic thing you need to understand about a computer language is that it kind of fulfills the acronym GIGA, which means garbage in, garbage out. Computers are explicit and literal, which means they do everything you tell them to do and nothing of what you don't tell them to do. And what that means is that if you don't tell them exactly and in very detailed, this is how I want it done, this is how I want something formatted, do the directions of these things, it's not going to be able to read your mind. So they're not going to, in a sense, to things that you suggest or you hint at, the computer's not going to do that unless it's actually in the program. The other thing is that it's literally going to do what you're in the program, which means that you might have intended one thing, but if you wrote something else in the program, it's going to do what you wrote, not what you intended to do. And as a result, when you approach writing programs, you have to kind of go at a different way than if you were going at normal human communication. Humans, compared to computers, we are mostly about implicit and figurative language. So we can use things like metaphors and analogies. Very often what we say is interpreted in context by the setting. And so as a result, we interpret a lot of different things from this information that we pick up that's around the actual explicit thing that we're communicating. For me in a human language, I really learned this when I started to speak Japanese. And Japanese is a very implicit language where very often Japanese doesn't have pronouns. And so you infer what the pronoun is from the context of the situation. Very often they will drop, let's say, the predicate, meaning the verb part of the sentence in Japanese, because you're supposed to be able to fill that in. And what happens is that, if you were just literally reading Japanese sentences, or if you were just literally translating how people speak, you will find that we leave out a lot of things because those are filled in by our body language, they're filled in by our gestures, the context of the situation. And then there's metaphors that are not exact. So for example, just to use one that's not very much in current parlance, but if you say, for example, I feel as high as a kite, someone might interpret that like, no, you're not really high. The kite is high up there in the sky and you're here on the ground. That's not really true. But what you're trying to convey is making a comparison is that a feeling that you have, and then comparing it to, let's say, something that is unrelated. Computers really need explicit and literal directions, and you need to make sure that you are in every single step communicating exactly what you want to, and also that you're comprehensive and complete on this. I think that a very good sense of this from literature is Isaac Asimov, who's a famous science fiction writer. He has a series of books called I, Robot. And one of the chapters on Robot is called Roundabout. And it's about, that the engineers who are designing this robot, and the robot is malfunctioning, and they discovered that it's basically trapped in an infinite loop because it's doing what it's programmed to do, but then, it's in a sense not being able to break out of its loop. It's going round and around. And so you'll see this very often when we program is that if your loops are not contained, if they become an infinite loop, what's going to happen is that the computer is going to try to keep going around inside the loop. It's not going to have an escape. And eventually the program will collapse because it will use up too much memory, or you'll have an automatic shutdown of the computer program. And therefore you have to be very clear and make sure that your parameters are such that are going to allow a loop to finish. And I think as I said, I think the iRobot series of books are really good for understanding this, because one of the things they track is the development of a technology, how robots can go from very, very simple machines to very complex machines, and how humans are learning to communicate with them, and sometimes having to kind of troubleshoot and debug and figure out the process. And I really would encourage you to read this for yourselves, but also if you're serious about going out and programming, I think this is a really good book to kind of get some of the overall big picture things that you need to keep in mind. So let me talk a little bit about different types of errors. So like human languages, computer languages, there's more than one right way to communicate the same idea. So there's no exact one right way to code. There are wrong ways to code, there are definite mistakes, and there are things that you have to avoid, but there's more than one way to write a program for a particular task. Some of them are more elegant than others, some of them are more like better solutions, some of them use less lines of code. So the point about this is that, just like, for example, if you're doing a greeting for someone in a foreign language, there's more than one way to greet people. There's more than one way to ask, how is your day going? You can be direct, you can be indirect. And like in computer languages, there's more than one right way to write the program. At the same time, all the programs that are correct and are accomplishing the task are going to look similar in some way, because they're probably going to use the same structures. Now, the thing about this is that the key thing when you code is that you understand what your code does, what your program is doing. And so that's why I'm going to try to encourage you, like, there's a lot of examples of simple programs all around the internet, and it's very easy to go out there and find some code and copy and paste it in, assuming that it works. And I'm going to encourage you that if it's not something that I've taught you, it's not necessarily helping you finding the right code, and just in the sense that, well, I identify this and I'm turning this as my own work. Is because you're shortcutting the process of understanding what's going on. And there might be a reason why I'm showing you one way, at least as you're learning, to code using particular control structures or using particular conventions. It's not necessarily the way that a professional might write the program, but the point is that if you kind of jump to that and just use something when you don't understand, you're more likely to make mistakes, you're going to have trouble adapting it, and you're going to have trouble communicating what you're doing to other people when you're working with them. So I want to talk, though, about different types of errors. And the first type of error, and this is the error that will be kind of found when you compile it and it says, oh, error in a particular line, are syntax errors. And the question that syntax errors are trying to answer are, is what you wrote a correct statement? Which means, is this a sentence? So for example, if you have something like 2 plus 2, and the compiler asks, is this a sentence? It's going to say no, because 2 plus 2 is a fragment, it doesn't have a predicate, it doesn't say what 2 plus 2 is, and so the point is this is not a complete sentence, and it would reject this, saying like there's something missing here that you need to add. And that would be a syntax error, which means it doesn't have punctuation, it doesn't have, let's say, a key part of the sentence, meaning a noun or a verb, it's missing something, it's referring to something that is not clear or is not undefined. These are going to lead to syntax errors. Now, logic errors are not going to make the compiler shut down. If you only have a logic error and you don't have any syntax errors, the computer program is going to say, well, it's not going to know whether this makes sense or not. It doesn't really know what your intent is. It doesn't know what the program is supposed to do. It only does what you tell it to do. And as long as that you're communicating in, legitimate, command lines, and you're doing it legitimate, let's say, using appropriate syntax, it's going to try to do everything that you want it to do, even if, let's say, that's the wrong answer. So, for example, while a syntax error is saying 2 plus 2 is not a sentence because it's missing something, what a logic error is asking, and this is where humans have to catch it and why comments are so important, is that it's asking if the sentence makes sense. So, for example, 2 plus 2 is 5 is a perfectly fine sentence as a sentence. The problem with it is that it's illogical. We know that 2 plus 2 is not 5, and if a program was saying 2 plus 2 is 5, we know something is wrong with the logic of the program, and we have to find out what were the instructions and why they were incorrect from what we anticipated or what we intended to do in the program. So the main part here is we're going to talk about types of direction. So there are 4 types of direction. The first one is definition. And some things that are obvious to us or we take for granted are not obvious to a computer. Like, for example, what part is up? You can't just say go up. Up means something. So, for example, when you're designing a game and you want to hit a key that will move, let's say, a character up on the screen, you know, the computer doesn't know what that means. Oh, you want me to go up? What is up? Generally, what you have to do is that you have to define the coordinates. You have to give them reference points. Very often, and one thing that's a little counterintuitive for most computer programs, for most people, when we think of like coordinates, we think of the origin as in the lower left-hand corner of the lower left-hand corner, right? That's where it's 0, 0. But for most computers, 0, 0, which means the origin for the coordinates, is actually in the upper left-hand corner. And as a result, if you use coordinates like you've been doing in math, that's going to flip it for the computer, and it's not going to produce a thing, produce what you want. And so there's a lot of things we have to define. We have to say, what does it mean to add? What does it mean to perform a particular function? What is the name of this variable? What value does this variable have? Does this variable exist? Does this function exist? And so there are a lot of things that we're going to tell a computer which are basically defining the framework and defining the parameters of the program. And those are basically just orienting it so that it can so it can orient it in a way that's going to perform the way. But let me just give an example from everyday life in terms of directions, because some things are relative and some things are absolute. If you say go left, go right, okay, that all depends upon the orientation of the person who's getting the instructions to go left or right. So for example, if you're facing east, okay, right, if you're facing east, the south is on your right, north is on your left. But if you're facing west, north is on your right and south is on your left. Now, what might be better is that some things that are absolute, or maybe let's say cardinal directions like north, south, east, west, are still north, south, east, west, no matter what direction you're facing. And so something like that might be a more robust way to define directions and set the parameters if you're working, let's say, in a Cartesian grid. The second type of instructions are sequential instructions, which means in what order do you want them to execute the different parts of the program. So for sequence, and generally in C++, its default is that sequence goes from top to bottom in the code of the program, and then it goes from left to right for the most part, although sometimes when you're assigning values, it assigns values like from the right-hand side to the left-hand side when when you're assigning, let's say, a variable a certain value. Sorry. So there are some other things about sequence that it means that if you put the instructions, let's say, in a different order, you're going to get it, let's say, in a logical result, or you're going to get a result that doesn't make sense, or you're going to get a result saying it doesn't exist. So this might happen, for example, that sometimes people use variables before they declare them. So they're saying, use this variable called number1, and the computer doesn't know about a variable called number1. You don't define it until the next line. And so you have to be sometimes cognizant that you're declaring your variables, and you're at least declaring the prototypes of your functions before you're actually using them in the program. It doesn't necessarily need to be any particular place. It just has to be before you're actually calling for it inside the program. The third type of instructions are called iteration. Iteration is a word that you've probably heard reiterate, like to repeat something. Iteration just means one run or one loop. And if you might want to think of this in terms of repetition, that iteration is about repetition, which means that you're giving an instruction to repeat a certain process. Repeat this if something happens, repeat this until something happens. And so, for example, it could be something like a program for walking, which means you define something called a step. You say, keep doing steps until you're told to stop. And the point is that the robot will go, let's say, keep making steps or keep going forward in one direction until it receives another instruction telling it to stop. And finally, there's selection, which means do this or that, but not both, which means it's kind of like a fork in a road. And let's say if it gets one set of instructions, it's going to go through one path of the program. If you give it another set of instructions or has another set of values, it's going to take a different path in the program. And the easiest way of thinking about this is thinking in terms of a game console. If you're going a directional arrow, if you choose right, you want the computer program to go right. If you click on left, you want it to go left, which means you don't want it to go, if you go right, you don't want it to go left, and you don't want it to go in both directions. What you want to do is be able to select one path, whether depending on the user input or depending upon, let's say, a particular value. For example, you might have something where if you're doing a fighting game, which is that you want the fight to continue, but if, for example, someone's life level is below 0, you want it to say choose death, or choose death, or choose re-energizing, which means you might go to a different part of the program because one character, by depleting its life, is now effectively dead for the purpose of the program. The best way I think to remember this is to think in terms of an acronym, and I use the acronym called SID, although you can do DISS, D-I-S-S as well, because the order of the acronym doesn't really matter that much, and SID stands for sequence, S, I, iteration, D, definition, and an S, selection. So the first type of directions are sequential directions, and sequence is about order. And you've probably run into this when you've done math in terms of like order of operations, like PEMDAS. And this means that when you are evaluating an equation, you do certain things first, and this means that you'll get a certain result. If you don't follow that order of equations, the way you evaluate the equation is going to give you a different answer. In C++, as I said before, the default sequence is that it's going to sequentially go from top to bottom, which means it's going to execute the commands at the top of your program before executing the next line, until it reaches the end. And it's going to try to execute them left to right. Now, it's not always going to be left to right because certain operators are read right to left, but that's basically, if you want to think about how it's reading through, it's going top to bottom and left to right in the same way that you might read a page. So why is this important? First of all, it's important for reading operators. So 9 divided by 3 is not the same thing as 3 divided by 9. 9 divided by 3 will return a result of 3. 3 divided by 9 will return the result of 1/3. So you need to make sure that your operators make logical sense given the way that they're set up. It's important for declaring variables. You need to be able to declare variables before you use them. If you declare variables after you use them, what's going to happen is that the computer is not going to know about the variable because it hasn't gotten to that point yet. It hasn't read the following line to know that it's coming up. And so you have to make sure that where your variable declarations are, where you say like, okay, there's an integer variable called number1 and it has a value of 5, is above in the program from when you're going to actually use, let's say, this variable called number1. And lastly, C++, unlike some other computer languages that rely upon indentation for their structure, there's a lot of delimiting punctuation. And by delimiting punctuation, I'm talking about things like braces and brackets and parentheses and curly braces. There's a lot of things where there's blocks of code that are kind of, let's say, set apart from the regular flow of the program. And these allow you to kind of tell them to execute what's inside these delimiting punctuations, what's inside the parentheses, what's inside the brackets, needs to be evaluated before something it sets the code apart from, let's say, the regular flow of the program. Our second type of directions are iteration or repetitions. And iteration is the same as a loop, and you probably heard the word reiterate, to repeat something. So iterate is once, reiterate is doing it twice or more. So iterations refer to structures that are loop control structures, and in C++ we're going to run into 3 of those. We're going to talk about while loops, which means something repeats while something is true. A do while loop, which is related to that, but it at least guarantees that you go through one iteration of the loop before it might terminate. And lastly, for loops, which we'll be using a lot, but are particularly helpful when we're dealing with arrays and vectors. So if you want to think of this, is that in terms of like some actual applications, you can think of walking as a loop of steps. So a step is one like function, and if you want to repeat that function over and over again, walking is just in a sense defining a step and then putting it into a loop that repeats until, let's say, continue walking until your position equals the wall. Or you can think in terms of most games, particularly real-time games, that it's basically a loop of plays. You want the game to continue until, let's say, you run out of life or when you run out of points, and then the game might terminate, or you have to put in, if you're an old school gamer, you're going to have to put into another quarter. Our third type of instructions are definitions, and definitions are usually either assigning value or declarations, which means you are telling the program that this variable exists. Definition declaration is that before you use certain things, you need to be able to tell the computer program that it exists. So for example, an At the top of most programs, you're going to have what are called pre-processing directives that I'll talk a little bit more in the next video lecture. So if you're including a class or you're including a library into your program, you have to be able to include it before it's actually being used or referenced inside the program. When you're using variables, you can declare them anywhere in the program, but you need to declare and sometimes initialize them before they're actually used inside some type of function in the program. You might need to provide function prototypes or function definitions before a function is used in a program. You need to talk about what types of variables. You need to define what type of data the variable is holding, whether it's an integer or it's a word or it's a character. And you need to define things in terms of formatting input and output. So there's going to be a lot of things where you need to make sure that you are defining something so the program understands what you're referring to, and when you give things particular names like variables and functions, that it can, in a sense, find those names and that you're formatting in the same way. Important about this is that C++ is case sensitive, so when you are giving something a name, it either has, capitalization matters, and so, for example, capital N number 1 is different than lowercase n number 1. It's not going to see that as the same variable. It's going to see it as two different variables, and the same thing with function names as well. Our fourth type of direction is a selection, which is basically a selection is saying this or that, and which means do this, execute this block of code or execute that block of code, depending upon the value of a variable or depending upon a certain condition that's existing in the program. And in C++, we're going to see selection control structures. And so these are going to be things like if condition applies, then do action. So you can have if condition inside parentheses, then action inside the curly braces. Or you can do something, for example, if condition A, then do action A. Otherwise, if condition A is not true, do a different action, action B. Or you can have ones that are branching, so you can have what's called if, else, if, else, if, else. And you could have infinite numbers of else ifs, which is you're basically saying if condition A applies, then do action A. Otherwise, if condition B applies, which means after you've excluded condition A, check to see if there's a condition B. If condition B, then do action B. And you can say else if condition C, else if condition D, so on and so forth. And so you can create like a multiple branching kind of selection structure that allows the program to go into different courses depending on values of variables or depending on conditions that you're setting up inside the program. And lastly, we'll use a selection control structure called a switch, which is basically a multi-fork selection, which is saying if condition A, then do this, execute this code, B, C, etc. And this is very useful when you have you're trying to filter your data. So for example, if your program is generating a certain values and you want to sort them into different bands, like for example, if your grades are between 90 and 100, you may want to give a message like, say, congratulations, you got an A. If your grades are between 80 and 90, you get a different type of message. But also in terms of gaming, it's like you can use a selection structure. For example, if player presses button A, attack, otherwise have your character defend. So selection structures are often used for things of this sort, and they're mostly acting as filters on the data, which means depending on the input you have, execute one block of code or the other block of code. So the application we're going to do for this is that we're going to write directions to build the tallest structure from a single sheet of copy paper or printer paper. So what is forbidden so the key thing here is not to do a design project and to impress me with your knowledge of structural engineering and your ability to build the tallest structure. The key thing here is that we want to write the directions for this. So we're going to write the directions, and we're going to write these directions, and then I'm going to give these directions to one of your classmates, and they're going to be kind of like the computer executing your program. And they're going to interpret it just like a computer is, explicitly, literally, and probably creatively misinterpret your directions, because very few people here are going to get very clear directions on the first try. So what you are forbidden to use in designing this is you can't use any adhesives, which means no glue, no tape, nothing of that sort. You can't use post-it notes. You can only use the one sheet, 8.5, 11 sheet by paper, or a second 8.5, 11 sheet by paper if, let's say, you can't use the first sheet anymore because you've cut it up or you've destroyed it. You are not allowed to use diagrams, which means your instructions cannot let's say, draw a picture. Drawing a picture is not going to help a computer understand what you want it to do, and so you're not allowed to draw a diagram. So you can't, draw like a little rectangle and then write little arrows about what you want to do at different stages. What you are allowed to use, or what you can assume that the person assembling your paper structure is that they have a ruler, so you can be precise about, let's say, specific lengths, and you can use a pair of scissors to make cuts into the piece of paper as necessary. What I want you to do, and each of you has a Google Doc in the Google Classroom to write your instructions. I want you to number each step, and that numbering will then take care of the sequence, which means when you give it to another person, they're going to do step 1, then step 2, then step 3, then step 4 as you number them. But otherwise, I want you to label each direction in terms of which type of direction it is. So if it's selection direction, I want you to say, okay, this is a direction and this is a selection structure, or this is an iteration structure, or this is a definition. So I'm going to end here. We're going to be working with you. I'll be circulating around, just talking to you about your designs. But just remember, this is not about, designing the structure. This is about writing instructions that another person who doesn't know and can't read your mind is going to execute from what you wrote down on the piece of paper. Okay? I will see you next time, and the next video lecture we'll talk about the elements of a basic program.